everyone. We are at Trig Graphs today. In this final lesson of the first semester, hooray, we made it. We're going to discuss the ACT briefly, get into the characteristics of trig graphs, and then we're going to connect the trig graphs in real life situations. Alright, let's get to the announcements, reminders, and updates. And I guess I'm gonna post these back here so in case you're watching from home, you know what to expect for the for this following week. Now here's the tea. I want to thank you guys so much on your improvements. You guys are really turning things around. You know, you're getting yourself engaged. You're trying to get in where you could fit in. I want to thank you guys for tidying up the classroom for me and for keeping me from staying all day just to, you know, remove food and all that. So when you guys keep tidy, you know, I could even go a step further and tidy up even further. You guys gonna see the difference, you know. 'Cause when you guys go, I swear, that classroom, you're gonna be feeling like it's at your house. It's gonna have, you're gonna see. I'm gonna leave that as a surprise for y'all. Again, the more you care, the more I do for you. The tutoring, I'll do more of that for you. The binder checks, you know, easy assignments to help you get your grade together. Now, tests will occur during Thanksgiving, after Thanksgiving, because I need for you guys to really have time to own those skills. Now, I'm not asking you for Thanksgiving break, oh, study the whole Thanksgiving, because I'm not thinking about school the majority of the days I'm on Thanksgiving break. I'll be eating food, doing all this, all that. So all I'm saying is, if you got me on Thursday, why not use Friday? Why not use Friday? You know, one of your off classes, electives that is, and then study Saturday or Sunday, and then enjoy your well. Friday, Saturday you're gonna be busy because everybody's gonna see their folks. Just study a little bit on the weekdays, you know, and then on Sunday study, and then you should be ready. All right. If you need my YouTube channel, there it goes. Theo-Toussaint Algebra-Math-Geek Howard. To pass, you guys really must show the skills that have been taught. Please, y'all, you gotta show your skills. All right. Test exemptions. Quiz exemptions. I'm not giving none this week. Everybody has to test because I have to see your skill. Now, some of you guys have unused tutoring points, meaning that you did not use for an exemption from tutoring. If you have not, those tutoring points, meaning 5, 10, 15, 20 tutoring sessions, will add on to quizzes and tests. If you got 5 tutoring points that you have not used, you get 10 points added to a quiz or test percent wise, meaning that if you got 50, you got 60. If you got 10 tutoring points that you have not used, not saying that you have used in the past but had not used, guess what? You have 20, and so on and so on. Our open notes, I decided to go on and restrict that. That's going to be cut. Everybody gets to cut on that because now I got to see if you truly know it. Open notes doesn't really show me what you know. It, you know, that's showing me, oh, you take good notes. So what I'm saying is, if you know your notes, you know how to do my test, no problem. Now, if you're a smart person, come tutoring this week unless I cancel it, and keep working in those tutoring points. So, you know, you could use them on your quizzes and that test when we get back. You could use all points on quizzes or tests. Doesn't matter how you use them. I would cancel tuning if I needs to. Don't put me in a situation that I have to. All right. So these are your testing concepts that I'm testing for. Precise definition of mathematics, factoring, all their types, polynomial graphs, evaluating polynomials, pre-geometry, geometric skills, unit circle, all proofs that goes back to polynomials, error analysis, definition and facts, and modeling. Academic dishonesty. I am very thankful and humbled that so many of you guys did come open about, you know, copying and stuff like that. And you was very honest. I love that about you. But here's the issue that goes with that. Many of you guys, when you copy, you want to pass it along as if you did all the work by yourself versus you doing the work. When you do that, that's called academic dishonesty because you haven't really did the work. You instead just didn't even try, and you wrote down someone else's work. Now it's different if someone, corrected your work and said, hey, this is wrong, this is the correct answer, and they gave you a reason of why. If they gave you a reason of why, meaning that you had something to show, and someone was like, hey, this is wrong, and corrected you, then that's different. That's not academic dishonesty because, someone saw that you made a mistake and they fixed it and they corrected you on it so you could fix it. So that's not a problem, but copying people's work and passing off as if yours and you did not hear me, did not do anything about it, that's a problem. It doesn't show what you know. Because many of you guys are stressing about passing this class. To pass, you gotta know the work. You gotta know something of the work. You cannot use the phrase, I don't know. I don't know means that you are going to fail the class. From now on, if you are copying people's work, you and the person who shall be punished. I'm punishing both. Because the person who was giving you work should have asked you to show them your work so they could, talk about, help you figure this out. Never, ever let somebody who did not do the work copy from you. Never let it happen. I know your work. I know I know you guys long enough to know, you know, your way of thinking. Also, still looking for a few more confessions. Please fess up if you did some dirt. Please fess up. And when you fess up about the issue of academic dishonesty, I will forgive you. I won't punish this once, but in future references, I will. Failure to do so will result in harsh consequences. So that means like if you choose not to fess up and you know you did dirt, you're gonna affect that for everybody. So that means like I could take away the vocabulary wall, I could take away bond check, I could take away these things. So I need for you guys to again show you care about doing the right thing, and when you show you care, I show I care. All right, let's talk about the ACT. The ACT is the only permanent exemption. So if you want to be exempt from all of my tests, all my quizzes, as if for all my work I only be responsible for classwork and district tests, guess what? This is what you have to have. A 20 on the ACT and an 85B in math. And let me clarify, in that 20, the lowest score of your math has to be at 18. You could score above 18, you score less than 18, but your score got to be 20 in all, but in your math has to be the minimum score of 18. Alright, so look, the ACT, first and foremost, is 60 questions long. 60 minutes long, and you got 60 questions, so 1 minute per question. This category, the biggest part of the ACT, is preparing for higher math. So the category covers the more recent mathematics students are taught, stating when students began using algebra as an generator of expression and solving equations. This category is divided into 5 subcategories. So, number and quantity deals with real number and complex number systems. Students will understand and reason with numerical quantities in many forms, including integers, irrational exponents, and vectors and matrices. Well, in my class, you've been taught the complex numbers. I have taught you that. We work with integer exponents. The vector and matrices is an advanced math subject that you will learn next year. You have to know algebra. So you have to solve, graph, and model multiple types of expressions. Students will employ many kinds of equations, including but not limited to linear, polynomials, which you know polynomial equations, radical, and exponential relationships. These students will find solutions to systems of equations. I'm teaching you that in January, even when represented by simple matrices. That's your senior math, and apply their knowledge to application. Those are word problems, which you know of 2 types for my class. Functions. Algebra 2 is heavily on functions. So this is what you be testing on. So knowing the definition of a function, notation, representation, and application. Questions may include but not limited to linear, radical, piecewise, polynomial, and logarithmic functions. Students will manipulate and translate functions as they find and apply important features of graphs. Ooh, yes, my ears. I'm sorry, y'all. Alright, and this function stuff is pretty much just saying algebra 2. The algebra stuff you saw, that was algebra 1. Alright, geometry. Define and apply knowledge of shapes such as solids, such as congruence and similarity relationships or surface area and volume measurements. Understand the composition of objects and solve for missing values in triangles, circles, and other figures, including trigonometric ratios and equations of conic section. So listen up. Most of the stuff you learned already, and you are currently learning, such as your trig ratios. And the big thing that is on the ACT is knowing the stuff that I have taught you guys for this 9 weeks. That is all there. In fact, that was the geometry session was one of our best sessions we have done at Estruma. Statistics and probability. This is all Mr. Howard. This is my baby. This is my favorite things to teach. So describe the center and spread of distributions. Apply and analyze data collection methods. Understand and model relationships in bivariate data. And calculate probabilities, including the related sample spaces. So we won't get into this till the spring semester. So I won't be really touching this till second semester. All right. So we cover those categories. Now we have a different type of categories, which is integrated essential skills. This category focuses on measuring how well you can synthesize and apply your understandings and skills to solve more complex problems. The questions ask you to address concepts such as rates and percentages, proportional relationships, areas, surface area, and volume, average and median, and expressing numbers in different ways. Solve non-routine problems that involve combining skills in chains of steps, applying skills in varied contexts, understand connection, and demonstrating fluency. So this is a big category. So that category is all about modeling. So this is the subcategory of that. This represents all questions that involves producing, interpreting, understanding, evaluating, and improving models. Each question is also counted in other appropriate categories above. So all the other stuff that you have seen that could count that also talks about that as well. This is a category of an overall measure of how well you use modeling skills across mathematical topics. Alright, when you take the ACT, it's always on the Saturday. But when you take it, you automatically exempt from homework. And I should dare say quizzes too, because how can you study if you test them? You know? You must show scores to prove that you have taken it. So we get into that a little bit later. You must know 48% of the material to earn the 20. Again, you only need to know 48% of the material to get a 20. Right. I already talked about that, so I already talked about that too. All right, so let's review. Oh, building a unit circle. I think we don't really need a definition, but on your test, you want to note the definition of a unit circle, which is a circle in the coordinate plane. Its center is at the origin, and its radius is 1 unit. The equation of the unit circle is x squared plus y squared equals 1, which we know Pythagorean originate from all of that. At this point, at the point xy, it starts at 1, 0 and moves counterclockwise around the unit circle. The angle theta moves from 0 to 360. So again, when we say theta, we're trying to find a missing angle or side of the unit circle. Alright? So we know that 0 and 360 have something special going on. So if you look at your unit circle, you notice something. All right, we have built the unicircle. There's a lot that we know about it. We built it from inside and the outside. You know, we talked about the important angles. We talked about converting from degrees to radians and vice versa. We talked about how we got the outside values. And we know when we see one, that means that the radius is either horizontal, and because the quadrant one is positive, or vertical, and because the quadrant one is positive, or because the radius is negative in quadrant two, between one and two is negative, and then three and four because it's between two and three, sorry, because the radius is vertical, you got negative one. So we know this unit circle, so I won't waste too much time talking about it. But in the beginning of all this unit circle stuff, I talked to you about the radius always being one. So this is going to play a critical part and it's going to, in some ways, undo the Pythagorean when you're dealing with the unit circle. And your Pythagorean theorem comes from your unit circle. But your hypotenuse is going to be replaced with 1. So this is the equation of the unit circle, which is a squared plus b squared. But because of the unit circle, we know that our hypotenuse, or our radius, is 1. That's a slightly difference between the unit circle equation versus Pythagorean. And of course, when we finalize the unit circle equation, cosine squared plus sine squared equals 1 is the complete definition of that. All right, we talked about these supported angles. We know that the 30, when we try to build our angles, the long leg is square root 3, hypotenuse is always 2, and then the short leg is 1. 45 is easy because we know both legs are going to be equal, which is going to be 1. But the hypotenuse of this is going to be square root of 2. And this when you're dealing with the angles, the degrees, the angles of 30, 45, and 60. And their reference angles are when you do all that. So 60 degrees has flipped because it's 30 degrees essentially. There's just the long leg becomes shorter and the short leg becomes longer. So hypotenuse is still 2 always for 30 and 60, but they short legged side legs, reciprocate. Now, I keep referring to this particular angle of 1 radius in particular when you're dealing with 1 and the comma 0. So take a moment and identify how many degrees is this right here, and here, and here, and here. So I'm going to ask you a question like name all degrees that has a radius of 1, in which if you look at your unit circle, you should know the answer to that. All right, we have converted angles from degrees to radius, and we double check our work from converting radians to degrees. And go from degrees to radians, you go degree divided by 180, radius and degrees, you're gonna go radians, sorry, times 180. So let's do 30 quickly. So you have to have good knowledge of rational numbers to be successful. So for degree to radians, you go 30 divided by 180. When you divide that, that's going to be 1/6. And we know that because you're dealing with a circle that has a circumference of 2 pi r, you're going to have pi in the numerator. And the one that's still there just becomes invisible, pi over 6. Now, let's go backwards, go from pi over 6 to 30 degrees. And to do that, instead of saying pi over 6, 1/6 times 180. 1/6 times 180 is going to give you 30 degrees. Now, when it comes to my test, am looking for those particular details. Be sure you know what you are doing. So yes, the calculator may give you the answer, but I gotta see that you know those details. So if you don't know rational numbers, please practice a review. I may throw them in the Kahoot review. New trig ratios, Pythagorean and the unit circle. Now, I'll bring this again. I asked you a question about, the degrees with the radius of 1. I asked you a question about the degrees that has coordinates of 1. Doesn't matter if negative 1, but 1, negative 1, those degrees, that's what I want you to know about. I'm not going to spoil the answer for you, but this is critical. So, you may not need a definition of this to write it down, but this is something I will be questioning you on your test. Ratios of a right triangle sides are used to define the 6 trigonometric functions. So I'm gonna ask you questions like to give me their names and give me their abbreviations. All right, now I'll be asking you details about those trig ratios too. So consider a right angle that has an acute angle theta. You don't know the angle, but that's what you're trying to find. The three sides of a triangle, the triangle, are hypotenuse, the side opposite theta, and the side adjacent to theta. And then the abbreviations are OPP, ATJ, HYP. And they are used to represent the sides of the triangles. So somewhere I am going to ask you a question with this paragraph, so make sure you know how to talk about it, write it down, explain it, bam, about these trig ratios that you've been taught. However, now here's something that's definitely going to be asked without a doubt. I'm probably going to be asked you questions, well, we'll be asking you questions about alternative ways of writing the trig inverses of cosecant, secant, and cotangent. So, when we say inverses, usually, now when you see cosecant, its inverse, multiplicative inverse for sure, is sine theta. Like, for example, if I was to ask you the multiplicative inverse, it's going to be 1 over 5. That's the multiplicative inverse. So be careful, because if I say inverse, I'm tricking you because I'm not being specific of what inverse. If I say like the inverse of cosecant, well, guess what? It could be negative cosecant, which is incorrect because you're dealing with ratios. It's 1 over sine, right? So that's the difference. So let's be careful with that. So cosecant is 1 over sine. Cosecant is 1 over cosine. Cotangent is 1 over tangent. So yes, you are responsible of knowing that because we'll be doing a lot of this practice in the tutorings. And of course, if I'm going too fast, always rewind. Mm. More details about trig ratios. So you know the abbreviations. So I'm gonna waste my time on that. But if you need them, there they are. All right. So in the previous homework, not the most recent that A-Day students turned in, but B that you are turning this homework in, I asked you to find the Pythagorean of this, to use Pythagorean, because I want you to get used to finding hypotenuse, because you guys have tendency of forgetting things. And it doesn't matter how many times I teach you, you are very forgetful. So I want to make sure that the Pythagorean was down to a point that I don't have to waste time on it. So, how do we find the Pythagorean of this? Well, you know that you have your x value, which is 5, and your y value is negative 1. I mean, negative 12. Now, I have told you I want you to use the Pythagorean way, so you're going to use the Pythagorean theorem formula. Oh, I'm tripping. So, 5 squared plus negative 12 squared over c squared. Now, I'm not going to explain to you how I got to 13 because you should be able to do this by now. If not, just please review Pythagorean theorem before you could continue on with this lesson. Please don't continue the lesson if you don't have Pythagorean understood. Please go back and practice the Pythagorean. All right? These are the trig ratios for that, and that's that. Again, I'm not explaining too much on this but now we should have this down to a science. Now, here's when it gets interesting, going to the unit circle. So usually, if you are not given if you only given coordinate x and y, guess what? You don't need the Pythagorean because you know x, you know y, and you also know your radius, and your radius is your hypotenuse. Therefore, it is 1. So with that being said, no need for it. All thing I do is now apply your trig ratios in this specific case. So ain't no op adjacent hypotenuse. You can say that, but you gotta use what you have, x, y, and 1. So sine is y over 1, which equals y. Cosine is x over y, 1 equals x. And then tangent is y over x, which is just y over x. But the cosecant, which is the inverse of cosine, is just 1 over y. I gotta be careful how I say 1 and y. So that's why I'm slowly pronouncing. Secant is 1 over cosine, which is 1 over x, and then cotangent is x over y. So we're going to try the same exact problem we just did with Pythagorean. Instead, we're going to apply these concepts. Now, again, you are given a coordinate pair. You are given a coordinate pair. So when it looks like this, a problem looks like this, you already know that the radius is going to be 1. So all thing you gotta do is just apply your trig ratios. So sine is negative 12 over 1, which is just negative 12. Now, what I want you to do is pause the video and try this on your own. Do the 5 remaining ones. So pause the video and just try it. All right, let's see what you got. So, if you know sine, let's start with the inverse of sine. So, if you know sine is negative 12, well, its inverse is going to be the multiplicative inverse of negative 12, which is 1 over negative 12. All right, cosine. Cosine is 5 over 1, which is just 5. So its inverse, secant, is going to be the multiplicative inverse of 5, which is just 1/5. And then tangent is going to be 1 over y over x, which is negative 12 over 5. And we know cotangent is the inverse of tangent, so we got to take the multiplicative inverse of that trig ratio of negative 12 over 5, which is going to be 5 over negative 12. So you can say inverse in terms of the trig, but in terms of the ratios, you gotta say multiplicative inverse, because the inverse of sine is cosecant. That's true. And when we get to cosecant, and you're like, well, let's talk about the details of that. It's just going to be 1 over sine. All right, not bad. All right, let's talk about trig graphs. Now, this, I will admit, is going to take some time getting used to, so that's why I'm trying to quickly finish up so we can practice and get things done. All right, I want you to pause and give this a try. Well, if you're looking at this correctly, you notice that this is the unit circle from 0 degrees to 360. And how you notice that is those radians at the top. You convert those all to degrees. So those are our special degrees I was telling you about with 0. Because remember it has 0, 1, 1, 1, all the ones and zeros. So 0, 90 degrees have that going on. 180, 270, and 360. Those are those important angles that has the coordinates of a 1 involved into them. So either it's going to be 1, 0 or 0, 1 or negative 1, 0 or 0, negative 1. What else do you notice about this? I told you something special about 0 and 360, right? So we notice that both sine and cosine repeat 1, 0, negative 1. That's a pattern going on. The maximum is 1 and the minimum is negative 1. Also at 2 pi, cosine returns to 1 and sine returns to 0 because at 0 degrees, sine was 0. And then when you get through with 360 like this, it goes back to 0. And cosine the same thing. It starts at 1, but then we at 0, but then we get to 360, it ends where it started. This is very critical for us when we are dealing with the trig graphs. All right, so here's some definitions that you may want to write details on. I know for my 1 and 3A, we just describe the picture and we put words to pictures, but here I want you to have a formal definition of this. The amplitude of the graph of each function, hear me, is 1/2 of the difference of the maximum and the minimum values. All right? And I will explain it to you in further details when we get to that. Each function is periodic, which means that its graph has a repeating pattern. So in order for it to be periodic, it has to be repeating. The shortest repeating portion of the graph is called a cycle. The horizontal length of each cycle is called a period. All right? And we're going to go back to the sine and the cosine stuff to get those details, which will apply to both amplitude and the period. All right. So, again, this is how we describe things. So, we have stated when we were trying to make some connections that both sine and cosine repeat 1, 0, -1. The maximum value is 1 and the minimum value is 1. At 2 pi, both cosine, at 2 pi, cosine returns to 1 and sine returns to 0. Sine starts at the origin and cosine starts at 1 when you referring to 0. Alright, so let's look at this carefully. So I want to get the amplitude together. So you have 1, 0, and -1, right? So that definition of an amplitude is talking about taking half of the sum of the minimum and the highest value, right? So the distance. So the distance between 0, because this is the middle is called the midline, and you're going to see that definition coming soon, from 0 to 1, because you're taking this distance from 0, which you guys going to be familiar with a particular old friend, and you're going to see that connection. So that's 1 right here, right? And from 0 to -1, this distance is still 1. So 1 plus 1, because it says the sum of those distances equals 2, right? And when you take half of that, when you take 2 divided by 2, it's going to be 1. So that's where we get the amplitude from. The amplitude is 1. Okay? All right. Now, we talked about the amplitude. The amplitude is the same from both cosine and sine. They're going to have the same exact amplitude. And I will be asking you something like that on your test, so make sure you know what's up. So 2 pi, because remember a period is the length of one cycle. one cycle, meaning that it started, it ended back where it started from. All right. So let me erase this. So let's look at sine again, because we know a sine of 0, that's still 0 degrees. It's starting right here, right? It starts at the origin, so it's 0, 0. And we know that at 0, 0, the graph increases. And what I'm trying to look at, when does it make that, when does it start making that pattern? It cannot be pi because although it's at 0 when it's at pi, but the graph decreases. But at 2 pi, at 2 pi, it increases, but it's also at 0. And that's when it makes this repetition. Because at 0, sine is 0, but then at 2 pi is also 0. Which that's when it starts making the repetition. So after 2 pi, it's going to be 1, 0, negative 1. And then another 2 pi, that's when it makes its cycle again. So that's two more cycles. So that's going to be 4 pi. That's the pattern. And then at 6 pi is the same thing, and 8 pi is the same thing. And it's the same thing from cosine. So at cosine, when the value of y equals 0 or the degree equals 0, guess what? Or the degree, my value is going to be 1. My value is going to be 1. My degree, when it says 0, cosine is going to be 1. But see, it's going to decrease. So I'm looking at where does it go back to start making a pattern. When does the pattern begins? There we are. When does the pattern begins? So at 2 pi, that's when it starts making its pattern because it goes back to 1, then decrease. So we look at sine of 0, cosine of 0 is at 1. But then when you look at 2 pi, that's when the pattern starts. That's this one complete cycle. All right, so more amplitude and the period. Ooh, yeah, I ain't gonna lie. I'm a little tired. I'm so excited that this is our last lesson because after this lesson, well, there's no need for no more videos, not even testing information. All right, so the amplitude of the period of the graphs y equals a sine bx and y equals cosine bx, where a and b are non-zero numbers, are as follows. So when you try to find the amplitude, as y'all saw me work from earlier, it was the distance between, the middle and its highest point and the distance from its lowest point. So, and I'll show you other ways of doing that as well. Right? 2 pi, the period. How is one say 2 pi first? So the period is going to be 2 pi over that distance of b. I wonder, what does this mean when you see these bars in between the number? Why don't you pause the video and see what that means? Welcome back. Now, if you say those bars are called absolute value, and absolute value is the distance between zero, you go ahead. You is one smart cookie. So good job. You know you all that in the bag of chips. I may be asking you that on the test. All right. Get your Desmos. We're gonna go ahead. We're gonna do this thing. We're gonna worry about the amplitude and the period. Point blank. I want you to do the following for me. I want you to identify the amplitude and the period of g of x equals 4 sine x. In decimals, you don't have to type in g of x equals, just type in 4 sine x. Just type it in. Then the graph function, then you're going to graph it and describe g of x as transformation of f of x sine of x. You're not doing this last part. This is what I want you to focus on. I want you to focus on this. When we have time, I'm going to show you that later. I want you to focus solely on this. Go to Desmos and do it. All right. You should have graphed it by now. I'm moving too fast. So if you have not done so, pause the video and go graph it and then come back to me. All right. So you got this function. A is 4. That's your amplitude. All right. Because you look at it, you look at the distance, you're going to get 4. And then B is 1 because this right here, the x has a coefficient of 1. So guess what? It's just 2 pi. So your period is still 2 pi. I'll explain this further in class. All right. So if you're struggling with this so far, I could explain this further in class for you. So here's my graph. All right. And your graph should look similar to that. I just, made it smaller. But we could get the decimals and work this together if you needs to. All right. So this is an important piece of information. So you can identify parts of it. So here, when we're dealing with these trig graphs, we need to know certain parts. A is your amplitude, which we already defined. K is going to be part of your period, and we know period is when it first started the pattern, meaning that if it starts somewhere, it should make a pattern at the end, starting back at the origin, meaning where it comes from. I don't know, for some reason I'm not talking right. But to help you remember, going back to cosine, cosine 0 degrees was 1, right? And then when you make its complete circle, meaning that its first cycle, at 360 degrees, cosine is still 1. So that's the best explanation that I could think of. So go back to that. Your phase shift is telling you when the graph moves left and right. Your D is the vertical shift, means going up or down. All right. So why don't you graph this function in decimals? Just graph it and see what will happen. Pause the video and try it. Before you talk to me about your graph, why don't we just look at the function? So the function has the amplitude. Can help us out with our period and help us with a vertical shift. So I'm going to show you what I have done. Be cautious because I have made a mistake somewhere, and it's your job to see have I done it right. The reason why I am throwing mistakes on this because I want you guys to get the practice of error analysis because I need for you to learn how to write and explain yourself. So I said the amplitude is 2, the period is pi over 2, the phase shift is 0, the vertical shift is 3. Did I get it right or did I get it wrong? Okay, draw your midline. That's the line, that's the in the middle between the highest and the lowest point. And your midline is going to be 3. Here we are. Did your graph match mine? Am I correct? Let's find out. We could talk more about this in class. All right. Now we're going to finally apply trig graphs to real life situations. All right. Pause this video and see can you state the precise definition of mathematics? All right. Welcome back. Let's see what you got. If you had said math is the technique to explain, understand, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment, excellent work. That means you are ready for my test because this is definitely my go-to question because I need for you to know this definition like a champ. Know it well. I may even, ask you a question of how did we set out the precise definition of mathematics dealing with trigonomic functions or graphs, in particular the graphs. All right. Of course, I'm gonna ask you to let's describe the two type of mathematics. Abstract. So all the definitions, including the precise definition of mathematics, that's all abstract. That's all like for the mind. The applied stuff is when you take the stuff in your mind and applying it to a real life situation. Why does this matter to us? Why do we care about trig functions? So, why don't you pause the video and look up application of trig functions? I mean applications of trig functions in real life. Pause the video, look up, and see what you can find. Pause the video. All right. Welcome, welcome, welcome back. Welcome, welcome, welcome back. So, let's look at this first, and then let's see the importance of it. The periodic nature of a trigonometric function makes them useful for repeating patterns that occur in real life. In those situations, the reciprocal of the period is called the frequency, which gives us the number of cycles per unit of time. When I look at this information, and of course, anything that I bolded, write down, please, because that's something that I will question you on. Um, I think of heart rates, boom, 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 boom. You know, I think of temperature, you know. So let's move on. All right, this first example, we're going to be dealing with sound. So if you guys who are who are musically talented, went to a studio and you watch, people, doing the recordings, you see, the device working about their vocals. It goes high, low, right? So that example, pure tone, is coming from that. A sound consistently of a single frequency is called a pure tone. An audiometer produces pure tones to test a person's auditory functions. An altimeter produces a pure tone with the frequency F of 2000 Hz cycles per second. The maximum pressure produced from the pure tone is 2 millipascals. Write a graph, write and graph a sine model that gives pressure P as a function of time t in seconds. Woo, that's a lot. That's some vocabulary that we like Pascals. Oh my God, I'm not doing the word problems. You guys, I'm testing you on this, so you gotta get over yourselves. So let's break this down. So before we get back to the answer, back to the problem, there's some information that we gotta know. Graphs of sine and cosine functions are called sinusoidal functions. That's a word, isn't it? Sinusoidal. Let's say it again together. Sinusoidal function. Wow. So some people pronounce it as sinusoidal function. So you could say either or. So you could say sinusoidal or whatever. But if I were you, I would stick with sinusoidal function. It's just easier to pronounce. So one method to write down the sine and cosine function that models a sinusoid is to find the values of a, b, h, and k for those trig functions. Now, functions that are used in reality are called models. So when we're dealing with real life situations, call them models because that satisfies the precise definition of mathematics. All right, now let's get back to the problem. What was given in that situation of the sinusoidal problem? You was given a frequency of 2000 hertz per cycles per second, and then you was given an amplitude of 2. So, what is required, we gotta write and create a trig function based off the information given. So, let's do the frequency, which is 1 over the period. So, your frequency is given in terms of 2000, and the reciprocal of the period is going to be b over 2 pi. Now, we don't know what b is at all, but to make that happen, we want to multiply everything by 2 pi, which gives us 4000 pi, which gives us b. And that's going to help us represent the period. So with that being said, the pressure P as a function is given by the model P equals 2 sine 4,000 pi time. This is what you have to do, right? And the graph looks something like this. This is that graph of that. So we meet like this, we good. All right. Now, your last example is now you're given a value, a table of values. Now you gotta plug it in. So in Desmos, you could plug this value into the table, which I'll show you in class. But if you plug this in, remember, t is your x value and y is your n value. So let's go over this example. The table shows the numbers n of hours of daylight in Denver, Colorado, which if you have not been there, go there. It's a very pretty place. On the 15th day of each month where t equals 1 represents January, you're going to write a model that gives n as the function of t and interpret the period on the graph. Now, I will teach you this in the calculator as well, but I think for the time being, I want you to do this in decimal since you're going home doing this. All right? So, when you put this in decimals and all this other stuff, this is what you're going to get. According to our computing device, the model that best represents the situation is n equals 2.76 hundredths sine times plus 511 thousandths minus 1.59 hundredths plus 12 and 1 tenths, where the amplitude is 276 hundredths and the period is 12, which it makes sense because if you look at it, you know, this is January and then 12th of December, so the temperatures are pretty much the same, you know, when it makes that cycle, that one complete cycle. All right, I know this is a long lesson. Some of it we're going to do in tutoring, and then you're going to get your review, and you should be good and ready to pass this test. It was a pleasure making these videos, but man, I'm so happy that I don't have to do no more because we have finished all our lessons.